Hello everyone! Today we are going to learn the use of automotive oscilloscopes. In a hands-on class on troubleshooting, the vehicle instrumentation malfunctioned as shown below. During the diagnostic process, the CAN bus needs to be measured because the CAN line transmits pulsed signals. An oscilloscope should be used as the measuring instrument. The main features of the handheld oscilloscope are dual channels, automatic waveform state setting, waveform setup, interface storage, and waveform and setup reproduction, various waveform mathematical operations, edge video, pulse width, alternating trigger function, fine window expansion, precise analysis of waveform details and overview, cursor measurement function, etc. The oscilloscope panel is divided into two areas, the display interface and the digital oscilloscope operation panel. Let's look at the display screen to see. Firstly, display the status of the trigger source. AB indicates that the corresponding channel of the digital oscilloscope is used as the trigger signal source. Secondly, display trigger coupling method. This symbol indicates the wavy line AC trigger coupling method. This is the general trigger coupling method. This symbol indicates the DC trigger coupling mode. That is, both the AC signal and DC component of the trigger signal can be sent to the trigger circuit. This method is suitable for observing ultra-low frequency signals. This symbol shows the high-frequency suppression mode and the suppression of AC signals above 80 kHz in the trigger signal. This method is suitable for observing low-frequency signals. This symbol indicates the low-frequency suppression mode and the suppression of AC signals below 80 kHz in the trigger signal. This method is suitable for observing high-frequency signals. Thirdly, this reading indicates the value of the edge trigger level. Fourth, display the status of triggers. It is shown as follows. This flag indicates that the oscilloscope is acquiring pre-trigger data. Ignores all triggers in this state. This symbol indicates that the oscilloscope has captured all pre-trigger data and is ready to receive and send it. This flag indicates that the oscilloscope has detected a trigger and is acquiring post-trigger data. This sign indicates that the oscilloscope has stopped acquiring waveform data. This symbol indicates that the oscilloscope is in the automatic mode and acquires waveforms in the no trigger state. This mark indicates that the digital oscilloscope continuously acquires and displays waveforms in scanning mode. Fifth, this shows the reading of the time from the trigger point to the center scale. Sixth, this icon indicates the power supply method. Seventh, the markers on the screen show the ground level of the waveform. An unmarked reference point indicates that the channel is not open. Eighth, 10 times the icon indicates the channel probe magnification is set to 10 times. In use, the channel menu of the digital oscilloscope can only be set in this way if the probe magnification is set to 10 times. Otherwise, the amplitude of the measured voltage will be expanded by 10 times. This icon indicates that the channel bandwidth is limited and that the bandwidth is 20 MHz at this time. M value indicates the main time-base mode and the corresponding time-base level. The operating panel of the digital oscilloscope contains the power button, acquisition mode and automatic measurement buttons, trigger system setup button, execute button, level system setup button, dials, and multipurpose knobs. It is easy to operate and control a variety of menus such as cursor measurement keys, store settings and screen copy buttons, auxiliary function setting buttons, maths function buttons, zoom function, and vertical system setup buttons. Next, we measure the high voltage interlock signals to get a feel for the basic measurements. Measurement of high voltage interlock signals in new energy vehicles. First, connect the pen to the oscilloscope. Second, press the oscilloscope power button. Third, set the attenuation factor of the probe menu to 1 time. Fourth, set the switch on the probe to 1 times. Fifth, ground the ground terminal of the meter pen reliably. Sixth, connect the A-channel probe to the backside point of the circuit. Seventh, press the automatic measurement button. The digital oscilloscope will be automatically set up to optimize the dial line display. On this basis, it is possible to further adjust the vertical and horizontal gears until the waveform display meets the requirements. Ninth, press the SOP button for the common function menu. 10th, press the F2 button to enter the parameter measurement menu. 11th, press the F1 menu again and select parameter measurement as specified parameter. 12th, press the F2 button to select the specified parameter as parameter 1. 13th, press the F3 button and use the dial to select the parameter to frequency. 14th, press the F4 again to select the channel as A. 15th, press the F2 button again to select the specified parameter as parameter 2. 16th, press the F3 button and select the parameter towards the seam value via the dial. Then press F4 to select the channel as A. At this point, we can see that the measured values for frequency and seam value are shown in the upper right of the display. Next, we look at line signals by measuring. Master the basic measurement method of handheld oscilloscope. Cursor measurement method to measure the signal voltage. The operation process is as follows. First, connect the pen to the oscilloscope. Second, press the power button. Third, set the probe menu attenuation factor to 1 times. Fourth, set the switch on the probe to double. Fifth, ground the ground terminal of the meter pen reliably. Sixth, connect the AB channel probe to the backside point of the circuit. Seventh, press the automatic measurement button. Eighth, the digital oscilloscope will be automatically set to optimize the dial line display. On this basis, it is possible to further adjust the vertical and horizontal gears until the waveform display meets the requirements. Ninth, press the cursor measurement button and the screen displays the cursor menu. 10th, press the F1 button. Open the cursor. There are 2 cursor measurement modes in the cursor menu, and the voltage and time. 11th, we measure the voltage value this time by using the F2 button on the panel, so that the cursor to be moved is a solid line. 12th, adjust the dial so that the cursor moves to the desired position, and adjust the position of the 2 cursors respectively. 13th, we can get the measurement dirt, V. At this point, we can see that the measured value has shown in the upper left of the display. If you want both cursors to move at the same time, press F4 so that the linkage is on. See you next time.